Well, no discussion of linear functions would be complete without at least some idea of an application that those lines go with. So let's talk about a linear function right here. It says the cost of manufacturing skis is $5,000 for startup and $80 per pair of skis manufactured. Some analysis has been done, let's say. The equation that describes the cost of manufacturing n pairs of skis is given by the equation C, that's the cost, is equal to 80 times n, 80 times the number of pairs of skis, plus $5,000. So this question has two parts. It says to graph this equation for the values of n starting at 0 and going all the way up to 2,000. Okay. The second part of this question is going to ask us to consider the point 59,000, which is on the graph, and write a sentence that describes the meaning of this ordered pair. Well, it will help for us if we're going to graph this equation to get 2 points. Now, 2 points that we definitely need to get. If we're given limitations like this one over here on the side, where we're told that n goes from 0 to 2,000, is that, well, we actually need to find the values for our value c, which is basically like y for us, when n is equal to 0 and n is equal to 2,000. So use those points. Use those endpoints. Let's check it out right here. Let's let n equal 0. Let's get c. Well, c will be equal to 80 times 0 plus 5,000. Well, very easy for us to solve right here. We know that that means c is equal to 5,000. On our graph, that means that if we were to plot this point, we would look for when x, which is n for us, is 0, c is equal to 5,000. So let's go ahead and plot that point. There it is. Okay. Next, we need to find out what happens at 2,000. So we're going to use that point. If we let n equal to 2,000, let's find out what happens. Our cost is going to be the number 80 times 2,000 plus 5,000. Now, I know a lot of people look at those zeros, all those zeros, and think, oh my gosh, what's going to happen? Well, in fact, there's a really easy trick that we can use. We know that 8 times 2 gives us 16. The only question is, how many zeros are going to follow it? Well, you've got 3 zeros right here. We've got 1 more 0 right here. And in fact, that number of zeros is going to equal 1, 2, 3, 4 zeros, 160,000, plus an extra 5,000, which means that our cost at 2,000 pairs of skis is going to be $165,000. So it'll be $165,000 at the cost n equals 2,000 according to this equation. So if we're graphing this, now we're going to want to look for that point. And let's see if we can estimate it on our graph right here. Right, that means that here's 2,000 along our horizontal axis, and we go up and we find the number 165,000. 165. Well, let's see. Let's go by these. 5,000, 10,000, 165,000. Let's change that scale a little bit right here. Right. And our scale should reflect this part. Let's get rid of that line right there. Let's plot this thing. Let's see what's going to happen. Oops. Doesn't like to play, does it? All right. Let's see if we can. No, come on, come on. Let's get that little. I'm going to drag this equation out right here and just that way I can deal with the box right here. There we go. Oops. Yeah, we made it too big. Let's see if we can change that scale vertically right here. Take our hand right here and scale this up. We want to start at 0. And we want to go up, 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 up. Okay. Well, for whatever reason, our scale isn't working out with us. This is what it's going to look like right here. We want to go out to 2,000, but our top of the line right here, we might want to just scale that up right here. So let's pause here and do that. Okay, well, let's see if we can fix this now. Let's take a look at what our graph looks like. There it is. Okay, beautiful. We had to adjust our vertical scale a little bit right here. And we can see that the graph certainly does pass through the point 2,000, 165,000, well, maybe a little bit below that, right? So if we wanted to actually get the end point right up here, it's right in between these 2 points, right? So we can kind of see where that's at. It says that the graph, the point on the graph, 59,000. 59,000 is on the graph, so we go over here. 100,000, let's see. We've got it in the middle there somewhere. We can't really plot on it, but let's say it's right about down here. Right, we can kind of see where that's at. I'll put it down here just so that we can point out. This would be the point 59,000. Right? If we wanted to plot this out. Well, what is that meaning? What is the meaning of this ordered pair? Because that will be helpful for us to know. Well, let's write it out. What do we mean? Well, we could state the following. If n equals 50 pairs of skis, pairs, and spell that correctly, pairs of skis are produced, what do we know? Then the cost of manufacturing, adjust the size of this so we can fit it all in. The cost of manufacturing will be $9,000. Right? Seems pretty straightforward, but once you get the idea of what these graphs actually represent, this is actually sort of an easy idea. Good luck with your own graphing assignment this week. I'll see you in class.